Yeah, hello all together, and welcome to the presentation how to close the water loop. We from INTEWA, we want to use the available sources of rainwater, grey water and black water and return excess rainwater to the groundwater reservoirs in order to ensure a safe drinking water supply and to avoid the flooding. My name is Oliver Ringelstein, and now I'm 30 years passionate for water reuse and stormwater management. I founded company INTEWA, and we are a company in Aachen, which is in Germany, very close to the Belgium and the Dutch border. Now to the interesting question: is a decentralized and self-sufficient water supply possible today? 5 years ago, we were able to construct our own building. So 2029 we started. We have a plot here in Aachen, which is 3,000 square meters, 350 square meters office, 350 assembly and development, 500 square meter warehouse, and approximately 1,000 square meters of open space. I can recommend you our webpage, building.intewa.net. And here you can see the whole development of our construction, so from the field up to the existing situation now. First of all, we are catching the rainwater from our warehouse. The warehouse roof is 500 square meter, and here we can collect around 400 cubic meters of rainwater a year, and this water is used for the is filtered with our pre-filter systems. So the pure rain filter to remove the coarse dirt from the water, and then afterwards we filter this water with the AquaLoop ultrafiltration. And the ultrafiltration, you can see this here in this vessel, in the silver vessel here. This ultrafiltration removes all the particles bigger than 0.02 micron. And this, just to give you an idea how this, what this means, is that a virus, for example, a coronavirus, is larger than the 0.02 micron. So we remove the virus and the bacteria and all the particular dirt from the water. After this treatment, the water is pumped with our pump and control units through the active carbon filter to remove odor and taste from the water. And then it is going through the UV disinfection into our grid from the building. The water then is used for everything which is potable. So this can be our coffee, our tea, but washing the hands, so everything where you need potable water quality for. The water requirement is only 80 cubic meter in a year, which is not a lot, but what we do with the remaining water, I will explain later. The second possibility to save water, or we call it the further water source, is the effluent from the wastewater. And in our building, we wanted to test this as well. We have installed an own small sewage treatment plant. The yield, so the water we can get from this plant, is about 100 cubic meter in a year. This water is from toilets and from kitchens, so it's the so-called black water. The water requirement is around 60 cubic meter in a year, and the water after the treatment process is used for flushing the toilets, but also can be used for washing machine or for irrigation purpose. The cleaning process is similar to the mentioned before, but we have a further biological treatment process and then afterwards a disinfection with our ultrafiltration as well. The green roof also is a source to collect water, so to collect rainwater. But here the situation is that the water we can collect is only a small part of the water we can we harvest here, because 70% of the water, the rainwater, will stay at the green roof, and this water directly is used for the irrigation of the plants or for the evaporative cooling. So this means that all the water which is evaporated is cooling the environment. If you count this together, then you will end up with around 120,000 kilowatt hours in a year of cooling energy. So this is an important part of the environment in our very close or just above our building to cool this environment. So the further 30% we can catch in our rainwater harvesting tank, this again is filtered and then used for the irrigation of the green roof. For example, at the moment we have a test system running on the green roof where we plant our own vegetables. And of course, in the summer period, in the dry periods, we need water to have a nice green roof. If you don't irrigate a green roof, the green roof does not have a lot of nice plants, as you can see here from the picture. So it is too dry in those dry periods to run a green roof without irrigation. Furthermore, we have the infiltration and detention. So this is now not to collect the water, so rainwater. This is to get rid of the rainwater. Here we have the special situation in our company. We are on a layer of clay 6 meters of height. So this means normally this clay ground is not able to infiltrate the water with a standard infiltration technology. So here we are working with the recycled plastic grids all over the 1000 square meter to have a huge surface. Underneath this surface, we have a layer of 50 centimeter of gravel. So after the rainwater is passing the permeable plastic grids, it is collected in the 50 centimeter layer of gravel and it is stored here. So because we need this huge volume, because the level of clay can only infiltrate a small flow of water. So after the storage in this layer of gravel, the water is slowly going into the ground with this very small infiltration rate. So here with the clay, we have less than 10 minus 6 meter per second of speed where the water is going into the ground. With this water, we recharge the groundwater levels, which is very important for environment, and we avoid the flooding, so we are not connected to the public grid. And in case of heavy rainfall events, we are normally then in a lot of areas you have a flooding, for example. So in the middle of this slide, you can see our DrainMax tunnel infiltration system. And this is unfortunately, as mentioned before, which is not possible here for our situation because here we need a higher infiltration rate of the ground. Furthermore, we have 15% of the plot planted with trees and bushes, and here we do not need a special infiltration installation. So this is a natural area, and the rainwater then is collected by this area and is infiltrated and evaporated then in a natural way. Finally, as the conclusion, we can say, yes, a decentralized and self-sufficient water supply is possible, as we have shown here with our own company building. By the way, this is still probably the only company building in Germany which is water self-sufficient. It is interesting because we don't believe that it's very difficult. And so we believe that in the future, many more buildings can do this as easily as well. So altogether, we don't need water from the water supplier, so we are water self-sufficient. We infiltrate most of the water, so from 2,500 square meters of our plot is infiltrated, although we have a clay ground, which is a special situation. Only 500 square meters are connected to the municipality and within overflow. So altogether, we can say that we are water self-sufficient and energy neutral with this building. Now to the cost. With less than 500 euro a month, we have covered everything. So if you compare this with the old facilities, then we would have to pay 20 times more. So this means that it is not only sustainable, but it's also cost-wise very interesting to go in this direction. So now to answer the question, what about all the water we don't need? Yeah, we found a solution for this. We decided to produce now our own beer and lemonade, but it's not to sell something or to have a business model here, but it's more to explain to people that you can do much more with rainwater instead of simply flushing the toilet. So we easily can produce a potable water quality. And by the way, of course, the water is tested by a certified laboratory. We test all the water parameters from the potable water regulation. There are 50 parameters, and we always have the best water quality with this rainwater. As mentioned before, we have the two business divisions. The one business division is the stormwater management, and the other one is the water reuse. In the business division stormwater management, we have different solutions. We have the infiltration and retention of rainwater, but we also have the infiltration of the discharge water from a sewage treatment plant, for example. This water is collected in the tunnel system and then it is slowly infiltrated into the ground. So the water is coming from the sealed surfaces, from roads or from roofs, for example. Here you can see an example for the drain mix system. First, the water is going into our sedimentation and filtration pit, our row. Here, the dirt is collected, and later, after certain years, you can remove the dirt. We also have a system where we can monitor the situation in the whole system, and then we can remove the dirt after a few years to keep the system, to have the maintenance and to guarantee that the infiltration of the system is always working very well with our iConnect controller and monitoring system. After passing the pre-filter row, the water is going into the other tunnel elements and then also into the other rows. And from here, the water then is going into the ground, or in case we have a storage volume, then the water is collected and we can use it later. For example, here with our new capillary subsurface irrigation system. The capillary subsurface irrigation system has a liner. It's this EPDM material very often, but you also can use other materials installed underneath the system. So here the water is collected and it's not infiltrated. And because the water is inside of the system and the soil we use for covering the tunnel elements has a capillary effect. So here we have clay implemented in the gravel. So the water is not only going from above to the bottom, but is also going from the bottom to the surface. And so the soil is more wet than a standard system. This means that we rise the infiltration rate of the soil. And this also again means that if we have rainfall events with a higher infiltration rate, we can collect more water. And so this system is filled up with rainwater automatically better. And at the same time, we also avoid the discharge of the water from the sealed surfaces, so we have a higher detention or retention volume. The system can be installed in cities, for example. It also can be used for growing plants, for vegetables, and so you can create a green area. You don't need to pump the water with a pump later to irrigate the plants. So this all is done automatically with this capillary efficiency. Now to our business division, water reuse. So we distinguish between the water sources and what we can use the water for. We can use different water sources to clean the water. First choice always is rainwater, because rainwater normally has the best water quality we can get. Then we have the gray water. The gray water is light polluted sewage water. So it's water from the shower, water from the hand basin, from the bathing tube. and this water we can clean this water to process water. We also can use black water as mentioned before, but further water sources are also river water or surface water. So what can we do with these water sources? So we can produce process water quality. Process water quality is used for toilet flushing, for washing machine, for irrigation. We can use the water for cooling. This is called adiabatic cooling, which is the most efficient way to cool the environment. And just by evaporating, so the same with the green roof I mentioned before. And then a further water quality is hygienic water quality, which is not existing in Europe, by the way. And then the last and highest standard is the potable water quality. Our systems are designed in a manner that we have ready to connect the packages. So this means those systems from a very small, for example, from a single family house, here this Aqua Loop system, 300 liters a day, for example, which is suitable for 4 people, maybe up to bigger systems, 50 cubic meter or even more, so we can multiply the systems. For more than 1,000 people you can connect. Yeah, those systems can be used again, as mentioned before, as a grey water recycling technology. We can offer potable water production from rainwater or adiabatic cooling systems, or the reuse of the wastewater from the sewage water treatment plants. All the systems, the largest systems, are also equipped with our iConnect technology. So this means that we can not only monitor, but we also can run the system from everywhere. So from Germany, we have access then to the system if the customer wants to have this, and then we can check the system and run the system. Yeah, we are proud that now, meanwhile, the systems, the INTEWA technology is installed in more than 30 countries all over the world. And most important, of course, is that now our systems, meanwhile, are saving more than 5 million cubic meter in a year of water, and that our systems more than infiltrate more than 8 million cubic meters of water per year, so infiltration and avoiding flooding, recharging the groundwater levels. To our references, I have a few interesting references for you today here. So first, it is my private house in Belgium. So it's only 5 minutes from our company location in Aachen. Yeah, it's a typical single family building with 120 square meters and for 4 people. And I have installed the grey water recycling system. You can see here in this picture on the left side. I also then installed a few years later the potable water from rainwater system. And here I retrofitted the tank. This on the left side you can see the concrete pit here. It's a 10 cubic meter tank. And with these both systems all together, so the rainwater harvesting system and the grey water recycling system, now I'm most of the year I'm self-sufficient water supply as well. Interesting that in the last years we had a few dry periods, and this is getting worse and worse due to the climate change of more than 8 weeks or 9 weeks. And so after 8 weeks, my tank is empty. And even here with those both systems, I was not completely water self-sufficient, unfortunately, anymore. So this situation is getting more and more difficult. Future, of course, this means that we have to recycle even more water. We have to save water or find further water sources. A typical, a very, very interesting system for the grey water recycling technologies are apartment blocks, but there's also hotels, interesting sports centers, for example, or hospitals where the grey water recycling is very interesting. Here we have an example, grey water recycling for apartment blocks in Germany and Munich. And the systems are typically 5 cubic meters per day, so you can connect 120 people roughly to one system, but we also can have bigger apartment blocks or smaller, of course. And Greywater recycling in Germany makes a lot of sense, but in a lot of other countries as well. Why? Because here we can save the potable water and the sewage water cost. So the system can pay off within 5 or 6 years at a water price of 5 or 6 euro per cubic meter. So this means here the systems are financially seen also very interesting. The United States interesting because we have some areas, especially in California, but other areas as well, where greywater recycling now is mandatory. And because we are the only company with NSF 350 type commercial certification, which is the highest standard available all over the world, we were able to get some very nice projects here. This picture is the George Lucas Museum in Los Angeles, but we also equipped the Amazon headquarters in Washington, the Marriott Hotel in LA, and also the Barack and Michelle Obama Sports Center, and many other projects with our greywater recycling systems, not only for reuse for processed water, also for toilet flushing, but very often in the States also for the adiabatic cooling. Further interesting system here is the stormwater management for thermal spa in Eastern Germany. And we have 5,000 square meters sealed surface, so it's a roof and some roads, etc. And the water from this sealed areas is collected in our Dramix tunnel system. So here in this project, we worked with 150 tunnels, and there was a total storage volume of 300 cubic meter, and this water here is released then into the groundwater. It has a pre-filter. And interesting for these systems is that we can stackle the system, we can export the system. They are lightweight, so easy to install. And we have a high load capacity. Also, this system is certified by the DIBT, which is the German Institute for the Building Materials. Yeah, and now to the future project, our vision. The vision now is, as I mentioned before, even with greywater recycling and potable bottom rainwater, it can happen if you don't have enough area, or if you are in an area where we don't have enough rainwater. We need more water to be able to deliver to fulfill the water requirements and to overcome the climate problems with the long dry periods. So we have the new project. It's a new research and development project, the XNet WWR, so the Aiken Network for Wastewater Reuse. And here we connect the black water. So this means we do not distinguish, we do not separate between different water sources, so gray water, the light polluted water, and the rainwater, for example. Here we use the complete water from the black water, everything, and then we recycle this water in a semi-decentralized system. So this means here with this system we can connect several buildings, not only one building. We will offer different sizes in the future. The project is for 3 years. We started in January, so from next end of next year, we will have the first test result. The demonstrator will be installed in Aachen at the PIA Test Institute, and so you're also invited. We have an own web page, and you can follow the results and our findings from the web page. We also send around newsletters to explain about our experience, and the goal again is to deliver now different water qualities, so processed water quality, bathing water quality, hygienic water quality, and up to potable water quality. And we also want to reclaim the heat in this water and the nutrients of this water as well. So this, at the end, this would close the loop. The big advantage with such type of system that would be that it also is possible to retrofit this technology in existing cities, for example. Yeah, this is my last slide. Thank you very much for listening to my presentation. Our goal is that we want to solve the water problems altogether, and so it would be great if you give me a feedback. You can send me email, for example, to ringelstein@intewa.de and ask the questions. Ask the questions now. Yeah, thank you very much for joining this presentation here, and hope that we can work together in the future. Thank you. Goodbye.